So here is what I want you to type into Desmos. The first thing that we're going to do is we're going to write y equals the absolute value of x. Absolute value functions are what we are studying next. So these are straight lines. They're not parentheses. They're straight up and down. Quentin, you want to put the stuff away so we're not organizing binders or anything? We're just looking at this paper that I handed out. So y equals the absolute value of x. If you plug this in on Desmos, you have two different ways of plugging it in after you press the y equals. You can use this little keyboard down here, and that keyboard has the absolute value signs right there, so you can hit this button and then put the x in there, just type an x. Or if you look right above the enter key on your keyboard, it has a backslash, which looks like this, and then above the backslash it has those perfectly straight up and down lines, and so you can do shift backslash, and that's how you can get those absolute value signs. So y equals absolute value, do shift backslash. You can type it that way and never pull up this keyboard. So it's up to you. You can either pull up the keyboard or you can type it from the keyboard on your computer. Either way, doesn't matter. Okay, so this is what an absolute value graph looks like. I want us to fill in the table on our notes. So before that, I'm just going to draw a little sketch of what an absolute value graph looks like. If I look back on Desmos, that's just like a perfectly shaped V. So I'm just going to draw, starting here at 0, 0, I'm just going to draw a perfectly shaped V. That's what an absolute value graph looks like. Okay. And then I'm going to go back to Desmos. And to get a table on Desmos, if I want a table of values, I have to go up here and click on the gear. So everyone go up here, click on the gear on Desmos. And when you click on the gear on Desmos, it has these options right here, and one of them is a table. You can create a table. So go ahead and create the table, and now we have a table of values that we can fill in on our notes. Did I leave you a page for notes? No. Will you pass this to Addison? Thank you. Okay, so let's fill in the table of values from Desmos. So -2 corresponds to +2, -1 corresponds to +1, 0 is 0, +1 is +1, +2 is +2. So those of you who have learned this in the past might remember that the absolute value of a number always takes the number and it forces it to become positive. The absolute value always takes a number and it forces it to become positive. Okay, so we all have this written down, yeah? We're all good? Okay. So the next thing we're going to do is we're going to take Desmos and we're going to type this equation right here with the A and the H and the K, but when we do it on Desmos, I'm going to have you guys put a plus instead of a minus because it will be easier for us for the activity that we're about to do. So you're going to type it just like this. I'm going to go back and I'm going to delete the stuff that we just plugged in there. I'm going to type in y equals A, and then I'm going to do my absolute value. I'm going to do x plus h, and then I'm going to get past the absolute value sign, and I'm going to write plus k. So A, absolute value, x plus h, and then plus k. Did everyone get that? Plus h plus k. A in the front, then an h, then a k. We good? Plus h plus k. It looks a little different than your paper because your paper says minus h. We're putting a plus. Okay, we all have that typed in? And then it says add slider for A, H, and K, and then in blue it says all, and we're going to hit the blue. We're going to do sliders for all of these. And what I want you to do is go down here to the H and put 0 for H, and put 0 for k. We're going to leave those alone. And then what I want you to do is I want you to press play next to the a value. So press play. So if there's a number in front of the equation, a number for the a value, if the a value is positive, so here's some negative a values, there's some positive a values, we can see that positive a values make the v go up, negative a values make the v go down. Positive a values make the v go up, negative a values make the v go down. Does that make sense? Okay, so let's write that on our notes. We're going to say if the a value, if a is positive, then we're going to say the v goes up. If a is negative, the v goes down. And this, as a transformation of the graph, is called reflect over the x-axis. If the a value is negative, the graph has been reflected over the x-axis. That a value being positive is normal. It's normal for it to be positive. Negative is different than normal. It reflects the graph over the x-axis, puts the graph upside down. Okay, we good so far? We can see what that does? Okay. All right, let's go back to Desmos. So now, if we look at Desmos, I think that, if I remember correctly, pause. Yeah, okay, so here's what we're going to do. Click on the gear right here. Click on the gear. And what I want you guys to do is click right here. We're going to leave the H0, we're going to leave the K0. And we're going to tell the a value that the smallest number it can be is -3, and the biggest number it can be is +3. Smallest number it can be is -3, biggest number it can be is +3. Okay, and I think I'm going to press done when I'm done with that. I think there is a way to slow this down. Yes. Okay. If you click on this button right here, the animation properties, I'm going to slow down the speed because I want to see how the number for A is impacting what the graph is doing. Okay? So the two things I did is I clicked on this right here and I took my speed and I slowed it way down. I just don't want this graph to be moving quite so fast. I want to see what the number for A is doing to the graph. Okay? The other thing I did is I clicked on the gear up here and I changed it so that my A value at the very smallest was -3 and my A value at the very biggest was +3. Did we all fix that on our own? Okay, so now if I look at this and I press play, you guys can see that if the number is like a 3, if it's a -2, a number like this is kind of a big negative number. It makes the graph skinnier. But if I get a number that's closer to 0, if I get these decimal numbers that are more like fractions, like if I get something like 0.5 is like 1/2, or if I get a number like 0.3 is 1/3, or 0.25 is 1/4, do you see how that makes the graph really wide instead? So if it's a -0.25, then it's upside down and it's really wide. If it's a positive 0.4 here, then it's right side up, but it's really wide. If I take the number and I make the number big, now it's positive, so it's going right side up, but it's really skinny. Do Do you guys see the difference? So we can practice plugging some numbers in here just to see what the numbers are going to do. If I put a positive 5 in, that makes the graph really skinny. If I put a positive, oh, it won't let me put anything bigger than 3. Hold on, let me turn this off for a second. So if I put a positive 5 in there, it makes the graph really skinny. If I put a positive 1/5 in there, 1 divided by 5, 1/5, it makes the graph really wide. Everyone see that? If I put a negative 1/5 in there, all that's going to happen is that it's going to take the graph and flip it upside down. It doesn't make it less wide, it just flips it upside down. Everyone see that? Okay. If I take this and I put a negative 3, it makes it skinny, but it's upside down. If I put a positive 3, it's still skinny, it's just right side up. Okay, what's your prediction if I did a positive 1/2? What would happen? Positive 1/2. Positive 1/2, it would be skinny? Would it be upside down or right side up? It would be up. It would be wide or it would be skinny? It'd be wide? Okay, so let's try a positive 1/2. 1/2. Okay, so it'd be a wide graph. Okay, what if I did a negative 2? What would it do? It'd be upside down and it would be skinny. If I put a negative 2, it'd be upside down and it would be skinny. Okay, what if I did a positive 15? It'd be super skinny. Would it be right side up or upside down? It'd be right side up. So if I did a positive 15, it would be super skinny. Look how skinny that is. What if I did negative 1/30? It'd be the widest graph. Okay, let's do negative 1/30. Negative 1/30 is like super, super, super wide. Okay, what if I did 0.25? 0.25. It'd be wide. 0.25 is a fraction number. It's just written as a decimal instead. It would be wide. Would it be right side up or upside down? 0.25. It'd be right side up. So if I put in 0.25, let's do that. 0.25, right side up, it's wide. What if I did 3.75? 3.75. Skinny or wide? 3.75. Skinny, but it has a decimal in it.
But it's still a whole number.
It's still a whole number. It's just a whole number with a decimal. Okay, so it's a bigger number. So 3.75 would be a skinny graph. What about 0.75? 0.75 would be wide. Okay, so what's the difference between the wide graphs and the skinny graphs? Okay, so if the size of the number is small, it doesn't matter if it's positive or negative. If the size of the number is small, it makes the graph wide, okay? We call that a compression. So it's like you took a normal size graph and you squished it. Have you guys ever had like a hamburger that has a bunch of toppings on it so you can't like fit it in your mouth? Like it's got like lettuce and tomato and you put an egg on it and you put some onion rings on it and you put some bacon on it and you can't like fit it in your mouth. What do you do with that hamburger before you eat it? You take it, you smush it. You compress it down before you eat it, okay? So if the number is small, then it's a compressed graph, it's a squished graph, which when you squish it, it makes it a little bit wider, okay? So we're gonna say if the A value is less than 1, not 1 exactly, but if it's less than 1, if it's like a decimal or a fraction and it's a smaller number, then we're gonna say that this is called a vertical compression. And this makes, I wrote on my own notes, this makes the graph look wide. That makes the graph look wide, okay? If it's a bigger number, it's greater than 1, this is a vertical stretch. So you took the graph And it's like you held it like this and you pulled. You're vertically stretching the graph. You're making it really tall and skinny. Okay? Vertical stretch is a skinny graph. Okay. All right, so let's take Desmos. Let's put the A value at 1. Okay. Now what I want you guys to do is I want you to go down to your H value and press play. Okay, so what do you guys notice about the H value? What does that do to the graph? Yeah, it's moving along the x-axis. So this one is moving the graph to the left and to the right. And what types of numbers move the graph to the left, and what types of numbers move the graph to the right? Wait, but look at mine. So right now mine's moving to the left. Now it's moving to the right. What kind of numbers do I have? It's the opposite, right? So numbers that move it to the right are actually negative, and then numbers that move it to the left are actually positive. Do you guys see that, how it's kind of the opposite of what you would think? Okay, so let's write that down on our paper. So the H value, it moves it to the left and to the right, but it's the opposite of what we would think. Positive numbers actually move it to the left, negative numbers actually move it to the right. It's a little bit opposite of what we would think. Positive numbers move it to the left, negative numbers move it to the right. Okay. Anybody have any predictions? What's another way we can move a graph? What do you guys think the last letter is going to do? Probably move it up and down, right? That's another way we can move the graph. Okay, let's try it. So we'll go back to Desmos. I'm going to pause my H. I'm going to put the H back on 0. Okay? And now let's go down to K and let's press play. So this moves the graph up and down. Is it backwards like the H was, or is it what you would think? So it moves it up and down. So it's on the up part right now. Now it's on the down part. Now it's on the up part. Up is positive, down is negative. Okay, so it's moving the way we would expect it to move, right? Okay, so let's go ahead and add that to our notes. So the K value moves the graph up and down, and this is exactly what we would think. Positive is up, negative is down. So the part that's a little bit funky for us, that doesn't really make sense with our brains, is going to be the left and right. It's a little bit backwards. The part that we're probably going to have to refer to our notes on is this part right here. That's the part that we're going to have to keep looking back. Okay. All right, the vertex part we'll come back to in a little bit. So let's look at example 1. It has a 2 in the front. The 2 is positive. So if the graph is positive, is it right side up, or has it been reflected over the x-axis to make it upside down? It's right side up. Okay, so I'm not going to say anything about it being upside down. It's a positive 2. The 2 has the size of the number where it's not small, it's a little bit bigger. So if it's bigger, what does that mean? Skinny. This is a skinny graph, which means we're going to call it a vertical stretch. We're going to call this graph a vertical stretch. Okay? Now, this says x minus 3. So where the h value is, it has a negative number. If it has a negative number, does it move to the right or does it move to the left? It moves to the right. So this one has moved to the right 3. Okay? And then on the end, it has a number that is negative. If it has a negative on the end, does it move up or down? If it has a negative on the end, does it move up or down? Down. Down 1. Okay, so if we were to compare our graph with the regular V-shaped graph, our graph would be twice as tall, which would make it look skinnier. Our graph would have moved down 1, and our graph would have moved to the right 3 compared to the regular graph. Okay? All right, so let's go ahead and let's take Desmos and graph this one and then plot the points. Now, before we go to Desmos, we're going to figure out what the vertex is, because the vertex always helps me to know which points to plot. So the way that you find the vertex is you look right here. This gives you the x coordinate of the vertex, and this gives you the y coordinate of the vertex. And for this one, you know how it said negative, but it was actually to the right 3? So it was kind of the opposite of what we would think. It's the same thing when we find the vertex. It says negative 3, but when it gives us the vertex, it actually gives us a positive 3. It's always just the opposite of what you would think. It said minus 3, so it actually moved it to the right. It said negative 3, so it's actually a positive 3. Now this one, when it said minus 1, it actually moved it down 1. It did exactly what we would think it did. So this one, if it says negative 1, it's actually negative 1. Okay, so the vertex of our graph is going to be to the right 3 and down 1. I already know that. Now I'm going to look at Desmos to help me with the rest of it. So let's go back to Desmos. We can delete all of this stuff. We're done with this. And we're going to type y equals 2. We're going to get our absolute value symbols up there. And type x minus 3 minus 1. So here's our graph. It's a nice V shape, but it's a little bit skinnier than they normally are. Not a ton skinnier because it's just a 2. It's not like a 5 or a 7 or something like that. It's just a 2, so it's a little bit skinnier. And I want to get to the table. How do I get to the table? I click the gear, and now I'm going to click on the table. All right, now when I get to my table, the vertex is the middle of the graph. So I want to look for the vertex point 3, negative 1. I want to find that on the table, and then I want to get a couple points on one side of the vertex and a couple points on the other side of the vertex. My table is not even big enough to show me where the vertex is. It only goes to 2, it doesn't go to 3. So what I'm going to do is I'm going to put my cursor right here. Everybody find the cursor, put it right after the 2, and I'm going to press enter. There's my vertex. So now I've got 2 points on one side of the vertex, but I want some points on the other side of the vertex as well. So I'm going to press enter again 2 more times. So the vertex, that's my middle point. I want 2 points on one side, 2 points on the other side. Did we find it? We got our points? So I'm going to graph, I have the point 3, negative 1. Now I'm going to graph 2, positive 1. Over 2, up 1. I'm going to graph the point 1, positive 3. I'm going to graph the point 4, positive 1. And I'm going to graph the point 5, 3. So here's your vertex. You should have graphed this point, this point, this point, and this point. So 2 points to the left of the vertex, 2 points to the right of the vertex. And then you can draw your V shape. All right, did you get it? We're good? Okay, flip the page over. Let's do another one. This one has a negative in the front. What does the negative in the front mean? Yeah, it's going to be upside down. And when it's upside down, we call that reflect over x. Reflect over the x-axis. So this graph is going to be upside down. Instead of having a 2 in the front, this graph has a 1/2 in the front. So what happens if it has a 1/2 in the front? It's going to be a wide graph. If it's got a smaller number in the front, it's going to be a wide graph. And when it's a wide graph, what do we call that? Vertical compression. It's like you took your hamburger and you squished it. So you compressed it. That's the mathematical term we use. So we're going to say because of the 1/2, we have a wide graph. We call that a compression. Okay? Inside the absolute value symbols, we have a +1. What does the +1 mean inside? +1 inside, it's the h value, not up 1, it's inside, so it's the h value, left 1. Left 1. And then there is no number on the end, which means that the graph did not go up or down. It just stayed right in the middle. Didn't go up or down, it stayed right in the middle. Now, anytime mine does not have a number on the end, I like to put a 0 there because it helps me to figure out what my vertex is. So I'm going to put a +0. That usually helps me out. So my vertex, I use this number and I use this number. So this number says +1, but for my vertex it's not a +1. What is it? It's a -1. And then what do I use for the y coordinate? 0. So my vertex is -1, 0. And now I'm ready to go over to Desmos and type this in. So I can clear off what I typed before. I can type y equals -1 divided by 2, absolute value x plus 1. I can see there's my wide graph. It's not the widest graph we've ever seen, but it's still kind of wide. And I want to look at my table. How do I get to my table? I press the gear, and then I press the table. And this time we can see the vertex. There it is at -1. But we need some more values because we only have one value on the other side. We don't have two. Say it again. To get the table, we press the gear button, and it has this right here to create a table. Yep, perfect. Okay, so we have the vertex right here, but we don't have 2 points like we want. We only have one. So what we need to do is put our cursor right here with the -2, and we're going to press enter. And unfortunately, it's not quite as nice as it was when we do after +2. If you go after +2, it just puts the values for you. If you go after the negative, you actually have to type in the values. So I'm going to type -2, -3. If I wanted more values than that, I have to keep pressing enter to give myself more spaces so I can type more numbers. Okay? Now, if you don't want to graph the 0.5s, if you would rather graph the whole numbers instead of the decimals, you could give yourself even more spaces and then skip the decimals and only graph the whole numbers. That would be fine. So you could say, I'm going to graph this vertex, I'm going to graph this point. Nope, I'm going to skip that point because it was a decimal. I'm going to graph this one, skip this one because it's a decimal, and then graph this one. You could do that if you wanted to not graph the decimals. That would be fine. And I think that's what I'm going to do. So I'm going to skip the decimal and graph -3, -1. I'm going to skip the decimal and graph -5, -2. And then in the other direction, I've got 1, -1. And I need some more points to be able to graph another one. So I'm going to press enter. And then 3, -2. So here's what my graph looks like. Okay. We comfortable? All right. Okay, next one. Now this one, inside the parentheses, well, not the parentheses, but inside the absolute value symbols, it does not have a number. So what number could you have that you don't even have to write down? 0. So this graph is actually y is greater than 4 times the absolute value of x plus 0 minus 5. That's what this graph must have been, and that's why they didn't even have to write anything down for it. So what transformations can we see? We have a 4 in the front. What's that going to do? Skinny. And what's skinny called? Vertical stretch. Okay. Oops, don't have to write out vertical. I can just say V. Vertical stretch. Okay. There's a 0 inside here, so what is not happening? Which direction, which 2 directions are we not moving? Right and left. There's no right and left. It's staying right in the middle. No right and left. Okay, what about this one? What is this one doing? Up and down. And which one is it doing? Down. So -5 is down 5. Okay? And let's go ahead and figure out what the vertex is. So it comes from this number and this number. And this is kind of a trick question. If it says +0, then what's the vertex? -0, but -0 and 0 are the same thing. It's just 0. Yeah. Okay, and then what about the y coordinate of the vertex? -5. Yeah, you keep it exactly the same. -5. So 0, -5, right down here. Okay. All right, and then I'm going to go ahead and go back to Desmos and type this in. Now, you can type the version in with the 0 or the version without the 0. It does not matter. So you can do x plus 0. I'll show you guys how they're the same. So there's our graph. You can put the version with the 0 like this or without it. They look the same. So it doesn't matter which one you put. And then I'm going to go ahead and click on the gear and click on the table. And there's our vertex, 0, -5. So our other points, we have -1, -1. And -2, +3. And +1, -1. And +2, +3. So you can see, here's all the points that we're graphing. Okay, and this graph is actually an inequality. So does this one get a dotted line or a solid line? And think about the symbol. It's a dotted line. How do we know? It doesn't have the equal to underneath. So this gets the dotted line. Okay, dotted line. And since it's an inequality, what else do we have to do? We have to shade. Okay. So with a straight line, you would shade below the line or above the line, or to the left of the line or to the right of the line, depending on what the line looked like. With a V-shaped graph, you either shade outside of the V or inside of the V. Does that make sense? Those are like the two different sides you could consider, outside of the V or inside of the V. So let's go ahead and choose a point. I'm not going to use 0, 0 because I think 0, 0 in this case could be kind of confusing. So I'm going to choose the point 4, 1. I'm going to choose this point over here. It is outside of the V. So I'm going to use 4 for X, 1 for Y. 4 for X, 1 for Y. And I'm going to take my inequality and I'm going to plug it in. So 1 for Y is greater than 4 times the absolute value of 4 minus 5. Okay, can somebody remind me what an absolute value symbol does? It doesn't make it 0, but it does make it do something. It always makes it positive. Okay, so now because the absolute value sign, we're going to make it positive. Now, positive 4 is already positive, so I'm just going to leave that as positive 4. So now we have 4 and positive 4, they're right next to each other. That means that they're being multiplied. So 4 times positive 4 is what? 16. 16 minus 5 is 11. Is it true that 1 is bigger than 11? No, that is false. Okay, so the point that I chose is false. That means that outside of the V is false. So where does that mean the true points are? Inside of the V. So that means it's true over here, so we're going to shade inside of the V. Now, I didn't have to do that because Desmos would have done that for me. If we go back to Desmos, I can just change my equal sign, make it a greater than sign, and then we can see that Desmos shades the inside for me. Okay? But I did want you guys to be able to see how we could have done that ourselves. Okay, how do your brains feel? Can we find the transformations? Left, right, up, down, stretch. Can we find those in the equation? Can we use Desmos to graph the points? Yes, we can do that? Okay. So that's what your assignment is asking you to do today. Graph the points using Desmos, find the transformations.